Hello everyone, I am Dr. Padma Sai, Professor ECE, working for VNR VIGNANA JYOTHI, Institute of Engineering and Technology, and also serving as a chair, Student Activity Committee, IEEE Hyderabad section. So last class we have discussed elementary signals that are used in signals and systems, DSP and image processing. Now today we are going to study classification of signals. So already we discussed about continuous time and discrete time signals. For completeness of classification of signals, I also included continuous time and discrete time signals here once again. So signals are basically classified based on all these things. Okay, continuous time, discrete time signals, deterministic and non-deterministic signals, even and odd signals, periodic and aperiodic signals, energy and power signals, real and imaginary signals. Okay, continuous time signals defined only on continuous time. So it's x of t equal to sin. For example, for continuous time signal, x of t equal to sin t. Sometimes we are calling this signal as analog signal also. Discrete time is derived from continuous time signal by doing sampling of the continuous time signal. We will get, if you sample x of t sin t, you will get x of n sin n. The basic shape of the signal is same thing. But whenever your continuous signal is multiplied by impulse function, whenever both are present during that time only you will get output. The shape of the signal is same as your analog or continuous signal. So coming to next type of signal is deterministic and non-deterministic signals. So basically deterministic signal can be expressed in the form of mathematical formula. So irrespective of time, for example, x of t equal to sin t, if you substitute t different values, so it is not changing today or tomorrow or whatever it may be. Such type of signals we are calling as deterministic signal, whereas non-deterministic signal, sometimes we are calling these signals as random signals also. So we can't describe these signals in terms of mathematical equation. They are modeled in probabilistic terms. Here the shape of the signal is varying continuously. Suppose if you are measuring temperature today, so in summer temperature continuously varies. Whatever temperature today, for example, if you assume it is 37 degrees, you can't tell tomorrow the same temperature. So because of that, we can't predict this. Sometimes we are calling random signals as unpredictable. Deterministic signal, we can predict the value based on your t. Now coming to even and odd signals. So even signal is x of t equal to, if you replace t by minus t, both should equal to same, then we say that it is even signal. For example, if you take cos signal is always symmetry. So this is your cosine signal. So whatever value, for example, if you are taking 1 point, and this is minus 1, for example, assume this is 1, whatever value, amplitude of the signal at minus 1 is same as amplitude of signal at 1. Such type of signal we are calling as a even signal. Similarly, odd signal, if you take any cosine signal, sine signal, that is odd. So this is anti-symmetric about your y-axis. X of t equal to x of minus t. So even though that is equal to minus of x of minus t. Such signal we are calling as odd signal. So example here I have mentioned clearly. Suppose if you take pulse, it is having duration from minus t by t to t by 2. So whatever amplitude you are having at minus t by 2, the same amplitude is retained at t by 2. So it is satisfying that condition. So because of that, we are calling that signal as even signal. So similarly, I have mentioned here once again, x of t sin t, t is replaced by minus t. When you are replacing t by minus t, sin of minus t is equal to minus sin t. So because of that, this signal we are calling as odd signal. So now any function or signal can be expressed as sum of its even function as well as odd function. That is x of t equal to xc of t plus x naught of t. So you will get small problems in your course of study. So you have to test whether the given signal is even or odd, and sometimes you have to find even component of the signal, odd component of the signal by using these relations. Okay, so always whenever it is even symmetry, xc of minus t is equal to xc of t. When it is odd symmetry, x of t is equal to x of minus t. So whenever it is satisfying that, we say that is odd symmetry, otherwise even symmetry. So x of t equal to, I already mentioned. So suppose if you want to reconstruction, you require both even component and odd component. So x of t is both even and odd together. So always even part I mentioned, symmetry about the y-axis, odd signal is antisymmetric about the origin. So now coming to discrete or digital signal. So here also the same concept, only t is replaced by n. If n is replaced by minus n, then we say that it is even signal. For example, here you take your axis as already, whenever you are having this arrow, it is indicating 0 axis. All left side are -1, -2. So for example, if you want to draw this in terms of diagram, this is n, this is x of n, x of n. Okay, your x of n is taking these values. This is 3, this is 2, this is 2, this is 1. Okay, so now whatever value you are having at -1, the same value is existing at 1. So whenever it is satisfying that condition, we say that signal, given signal is even signal. So this is mostly even signal and odd signal concept is used in signal processing and image processing, Fourier analysis, signal decomposition. In many applications we are using this concept. Okay, coming to odd signal. So a signal is odd. In discrete case, all the same concept. If x of n is equal to minus of x of minus n, then we say that the given signal is odd. See here clearly. So now this 0 is arrow indicating 0 axis. So all right side it is positive axis, left side it is negative axis. So antisymmetric, I already mentioned. At 1 it is having value 1, at -1 it is having value -1. So because of that, that given signal is odd signal. Now coming to periodic and aperiodic signal. A signal is said to be periodic if it satisfies the condition x of t equal to x of t plus capital T. Suppose if it is a discrete signal, the same concept, x of n is equal to x of n plus capital N, where capital T is fundamental time period. In a discrete case, capital N is fundamental time period, where f is fundamental frequency, f is equal to 1 over t. So what is meant by periodicity? The same signal is repeating after certain interval of time, that we are calling as period. In this case, period is equal to t naught for the given example. Okay, so periodic means repeats over time. Aperiodic, it does not repeat after certain interval. So for example, if you take any EEG signal or ECG signal, or if you are measuring any sensor data, continuous signal, many times you will get aperiodic signal only. So always it has to satisfy the condition x of t equal to x of t plus t, or x of n is equal to x of n plus capital N. Then we say that the given signal is periodic in both the discrete case and continuous case. The smallest positive value of capital T is called fundamental period. For example, in this case x of t equal to sin 2 pi t, the signal repeats at capital T equal to 1 second. Hence it is periodic. So periodic signals mostly used in communication systems. Last class I mentioned, always we are using carrier signal as sinusoidal signal. So aperiodic signals used in real world applications like speech, pulses, and if you are measuring any temperature, so you don't get the same signal for all the time. Okay, for example, if you take x of t equal to e power minus t into u of t, so this is a periodic signal. If you calculate x of t plus capital T, you won't get x of t. So because of that, such signals we are calling as aperiodic in aperiodic signals. So no finite t exists for such signals. Okay, so if you take e power minus t, so what happens? It is decaying over time. As time is progressing, the signal is decaying and never repeats. So for example, what is meant by decaying? So for example, you consider this signal. So it is decaying. Such type of signal we are calling as aperiodic signals. Now coming to discrete case. Discrete case also the same concept. But here I am giving different examples. In periodic x of n is equal to sin pi n by 2. So in this case, your signal repeats every 4 samples. In the case of aperiodic signal, x of n equal to 1 by 2n. So if you calculate x of n plus capital N, you won't get x of n. So because of that, the given signal is aperiodic. Only difference between periodic and aperiodic is the signal won't repeat after certain interval of time. So if the signal is repeating after certain interval of time with the same period, then we call that signal as periodic. So already I mentioned applications of periodic and aperiodic signals, communication systems, DSP, oscillators, transient analysis, biomedical analysis. Most of the biomedical signals are aperiodic signals. Coming to energy and power signals. Okay, before going into energy and power signals, so actually why you require energy and power? What is the need to calculate power and energy of the signal? As a communication engineer, so when you're transmitting any information from transmitter to receiver, it is not possible to transmit along the channel. So our duty is we have to test whether the received signal is same or not, and what is the strength of that signal we have to measure by using these concepts. Okay, actually you're having area concept. How will you measure? Suppose we are having one pulse. Okay, so when you are having one pulse, it is having duration from minus t to t, and time axis is 2t, and having x of t. Okay, if I am having only one pulse, what is my aim? I want to measure the strength of the signal. So I can use the concept of area. By using area concept, I can measure strength of the signal. But so that is valid. Here I am using concept of area for measuring my signal strength. For example, you are having in one case, I am having signal positive as well as negative. Okay, so during that case, for example, I am having the same signal. It is 1 and this is minus 1. It is 1 and it is 2. Okay, when I am calculating area for this curve, whatever concept previously it is valid, if I calculate area for this curve, what happens? It is producing area under this curve is 0. But we have transmitted some information, but it is conveying information as received as 0. So I need some other measure to calculate strength of such signals. So during that case, I am using the concept of energy. By using energy, I am calculating strength of this signal. So the energy concept is valid here. Here area concept is valid. In this case, energy concept is valid. For example, instead of one cycle or finite duration signal, I am having signal from minus infinite to infinite, repeating in certain intervals. Okay, for example, I am having one signal, okay, periodic signal repeating from minus infinite to infinite. For example, assume. Okay, I want to calculate energy of such signal. So when you are solving problem, you will know how to calculate energy and power of the given signal. So before starting of the problem, I want to explain why we are going for different measures when you have signals of different type. In this case, I am having signal from minus infinite to infinite signal. If I calculate energy for such signals, okay, I already mentioned, suppose if you are having any pulse, so simply by using area concept, we are able to measure strength of such signals. Okay, that concept is valid whenever you are having positive pulse. For example, in a second case, I am having pulse positive, negative, having same duration. In such case, if I measure the strength of the same signal, this signal, for example, assume this as B, okay, during that case, if you measure strength, it is giving area under that curve is equal to 0. Whatever concept that is valid in the case of A is not valid in the case of B. So for that purpose, I required some other technique to measure strength of such signals. So it is having finite duration, whether it may be periodic or aperiodic. That concept, whatever previously used, is not valid. So because of that, what we are doing, we are going for measuring strength of finite duration signal by using energy concept. Now that is, I am able to measure energy for such signals. Now I am having another signal, C case. In C case, I am having signal from minus infinite to infinite. Assume it is a periodic signal extending from minus infinite to infinite. During that case, if I calculate energy, it is giving answer as it is having energy as infinite. But if you see here, it is having some quantity, but we are unable to measure. So because of that, we are going for some other measure. So that is power. We are calculating power. Instead of calculating energy from minus infinite to infinite, what we are doing is we are modifying equation only considering one period of the signal and limit t tending to infinite. I will show that equation in next slide. So these are because of that we got these three techniques. A signal is said to be energy signal when it has finite energy. A signal is having power signal. Whenever we are telling that signal is power or energy, it should produce finite values. Not if it is producing infinite value, then we say that it is not energy or power signal. Okay, a signal cannot be both energy or power simultaneously. Also, a signal may be neither energy nor power signal. This is also one of the important point. Generally, for power signals, power of energy signal is 0. Energy of power signal is infinite. Next, coming to the equations. So here, for calculating energy and power, so we are using these equations. So I already mentioned, if it is energy signal, always its value should be within less than infinite. Similarly, for power signal also, power should be less than infinite. So the equations to compute energy and power is given here. Suppose in the case of continuous case, only summation is replaced by integration. That is only difference. In place of x of n, it is mod x of t square dt. Okay, by using that equation, we are computing energy and power of the given signal. So in this case also you will get small problems. You have to check whether the given signal is energy or power. So if it is a power signal, calculate power of the given signal. So first state it is power or not. After that you have to compute that value too. So applications of these digital communication, signal detection and AC analysis and communication systems, these are used. Now coming to real and imaginary signal. A signal is said to be real when it satisfies the condition x of t equal to x star t. Similarly, a signal is said to be odd when it satisfies the condition x of t equal to minus of x star t. This is x of t equal to 3, then x star of t is 3 star. Already you studied in your intermediate also. This is a complex number. If you are considering any complex number, it is having real part and imaginary part. Similarly, whenever it is real signal, it is having only real part. If it is imaginary signal, it is having imaginary part too. Okay, for real signal, imaginary part should be 0. Similarly, for imaginary signal, real part should be 0. Suppose if it is complex signal, both real part and imaginary part is existing. So for example, and the same thing for in the case of digital case. So x of n is real, x of n is a complex. Complex means we are writing JBN. Okay, for example, if you take example of x of n equal to 1, 2, 3, 4, x of n equal to 1, 2, 3. So that is example for real signal and imaginary signal. This also used in complex signal analysis, communications, Fourier transforms. So audio signals, sensor outputs, in all these cases we are using real and imaginary signals. So before start of all those courses, you should be familiar with all these concepts. Then all those courses will be very easy for all of you. Now summary of this table, already I have discussed what is even signal, odd signal, periodic, aperiodic, energy and power, and real and imaginary signal. So now coming to another concept, causal and non-causal signals. So causal, if I ask you to tell story about some movie, so you can happily tell about the story. It won't change. Okay, for example, I want to ask what happened yesterday. So you will tell nicely the entire story. Okay, that is causal signal. So causal is talking about present as well as past things. Okay, such type of signals we are calling as causal signals. It depends on only past and present values. For example, if I ask you tomorrow what are you going to do, there is no guarantee what you are going to do. So because of that, we can't predict future. So because of that, we are calling that such type of signal as non-causal signals. A signal is causal if it exists only for present and past time. That is, no value before t equal to 0. For example, if you want to test whether the given signal is causal or not, x of t equal to 0 for t less than 0. The same concept is valid for discrete case also. X of n is equal to 0 for n less than 0. This concept is used in your DSP also for deciding whether your given system is causal or not. For example, except equal to u of t, except equal to 1 for t greater than or equal to 0. Already you know except t, u of t signal, u of t is u of t. Last class we discussed about u of t. It is having value 1 from 0, 1, etc. Okay, such signal we are calling as u of t. As for our definition, for t less than 0, its value is having 0. So because of that, the given signal is causal signal. All causal signals start from t equal to 0. If signal is starting at, for example, I will tell after a few seconds, if I am giving t plus 1. So t plus 1, so this signal starts from minus 1. So because of that, it is non-causal signal. This is non-causal, it is causal. Why? Your signal starts from minus 1. As for definition of causality, always your signal should start from t equal to 0. So non-causal signal, I already mentioned, a signal is non-causal if it has values for future time also. For example, you take previous case, your signal is existing at t equal to minus 1. It is having some value. Okay, except equal to not 0 for t less than 0, then we say that the given signal is non-causal. In this case, example, except equal to u of t. So in previous case, I explained only, so now in this case, your signal starts from minus 2. Okay, this is u of t plus 2. I will explain all operations on signal in next class. This is non-causal. Why? It is starting before 0. So it is starting at minus 2. Because of that, the given signal is non-causal. So I would like to thank all the authors of the books. So most of the content I am considering from all these books. Okay, I request all the students, so go through all the books, try to read. And Anand Kumar has provided a lot of examples, worked out problems. So please work on that. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.